Hello class, in this video I will be showing you how to evaluate a definite integral that requires U-substitution. Let's begin. In this example, we want to evaluate the definite integral from -1 to 0 of e raised to the 2x power, all divided by the quantity 3 plus e raised to the 2x power, all raised to the third power. This definite integral requires substitution, so I'm going to let u equal 3 plus e to the 2x power. The derivative of u with respect to x is 2 times e raised to the 2x power. If we multiply both sides of this equation by dx and divide both sides of this equation by 2, we will have 1/2 du is equal to e raised to the 2x power dx. Before we make any substitutions, I'm going to rewrite the definite integral into an equivalent form. This step is not necessary, but it will make the substitutions easier to see. So what I've done is I've brought the expression from the denominator into the numerator by making the exponent negative, and I used the commutative property of multiplication to move the e raised to the 2x power next to the dx. U is equal to 3 plus e to the 2x power. E to the 2x power dx is equal to 1/2 du. If we make all the substitutions, then we will have this. Notice I did not write the limits of integration when I made all the substitutions. This is because the limits of integration are values of x and not values of u. To be able to evaluate this new definite integral, we will need to find new limits of integration that represent the variable u. We know that u is equal to 3 plus e raised to the 2x power. All we need to do is evaluate this expression for when x is equal to -1 and x is equal to 0, and we will have our new limits of integration. That will look like this. When x is equal to 0, u is equal to 4. When x is equal to -1, u is equal to 3 plus e to the -2 power. So our new definite integral will look like this. We have the definite integral from 3 plus e to the -2 power to 4 of 1/2 u to the -3 power. If we let lowercase g of u equal 1/2 u to the -3 power, then by the fundamental theorem of calculus, this definite integral will equal capital G of 4 minus capital G of 3 plus e to the -2 power, where capital G of u is an antiderivative of lowercase g of u. After applying the power rule, the antiderivative is -1/4 u to the -2 power. Now we will evaluate the antiderivative when u is equal to 3 plus e to the -2 power, and when u is equal to 4. That will look like this. When u is equal to 4, the antiderivative is -1/64. When u is equal to 3 plus e to the -2 power, the antiderivative is equal to -1/4 times the quantity 3 plus e to the -2 power, all raised to the -2 power. This number is not rational, which means we cannot write it as a fraction using integer parts. Now I'm going to take capital G of 4 and subtract capital G of 3 plus e to the -2 power. That will look like this. So we have capital G of 4 minus capital G of 3 plus e to the -2 power is equal to -1/64 minus the quantity -1/4 times the quantity 3 plus e to the -2 power raised to the -2 power, which is approximately 0.0098. So finally we have the definite integral from -1 to 0 of this rational expression is equal to -1/64 plus 1/4 times the quantity 3 plus e to the -2 power, all raised to the -2 power. This is approximately 0.0098. And we are done.